Hello, our project is on volcanoes. I'm Austin Crum.
I'm David Ryan.
And I'm Sean Zuzai. A volcano is a vent or rupture in the Earth's crust that allows lava, ash, and rock to escape a magma chamber below the surface. Volcanoes are found in three spots, two of which relate to tectonic activity. When two of Earth's tectonic plates come together, they form a convergent boundary. When one plate slides or subducts underneath another, it can cause a volcano to form, as a subducting plate melts, forming magma, which slowly rises towards the surface, creating a volcano. When two plates pull away from each other, they form a divergent boundary. As the two plates pull apart, they expose the magma of the mantle underneath. This magma then cools to form new ocean floor crust. Volcanoes can also be formed by what are known as hot spots, large mantle plumes of magma underneath a plate that expand towards the surface and form a volcano. As a plate moves over the hotspot, new volcanoes can be formed. This often results in a chain of islands such as Hawaii. There are 5 major types of volcanoes. Shield volcanoes are formed when lava slowly cools on the surface and flows a long distance from the volcanic vent, causing the flat and wide appearance. Supervolcanoes are formed from large calderas, formed when a large magma chamber collapses on itself, forming a depression in the land. These volcanoes are often the largest and are the most likely to cause massive eruptions. Subglacial volcanoes are found underneath ice caps, such as Antarctica or Iceland. Eruptions of these volcanoes can result in massive floods caused by the melting. Submarine volcanoes are usually formed by oceanic plate activity. More shallow volcanoes can form islands. However, at certain depths, the pressure and temperature of the water does not allow the volcano to erupt quickly, as the lava cools too quick.
Mount Kilauea is located on the southernmost island of Hawaii. In fact, Mount Kilauea essentially formed the southernmost island of Hawaii. It's the most active volcano on Earth. Kilauea has resurfaced 50 square miles of land in its 600,000 years of activity, and its current eruption period has been continuous since the beginning of 1983. Kilauea is formed by a hotspot in Earth's mantle beneath the middle of the Pacific Plate. The magma flows upward from the mantle and through the crust until it reaches the surface, where it forms basalt. Since there's always a fresh path for the magma to reach the surface, the magma doesn't build much pressure. Instead, lava flows out slowly, making for long, continuous eruptions lasting an average of 20 to 30 years. This type of volcanic eruption forms shield volcanoes, where the base is very wide and the peak is not very tall. The slope from the base to the caldera of Kilauea is just 2 to 3 degrees on average. This hotspot-style volcano is super important to geologists because it records the direction of movement of tectonic plates. In this case, the hotspot in the mantle is stationary, while the Pacific Plate above is moving. As the Pacific Plate moves, it carries the volcano above the hotspot with it. Eventually, the volcano is displaced far enough from the hotspot that it becomes extinct, and a new volcano forms over the hotspot. Looking at a map of extinct volcanoes near Hawaii, there's an obvious path of extinct volcanoes headed northwest. From this, we can gather that the Pacific Plate is moving northwest. We can also see that the volcano trail then turns almost directly north, with the oldest basalts found at the northernmost point. This means before the Pacific Plate was moving northwest, it had to be moving north. The sudden point of change is also telling us about the movement of the Pacific Plate. It changed directions relatively quickly. This chain is very important to geologists, and it is the reason why Mount Kilauea is the most studied volcano on Earth.
Yellowstone National Park is host to one of the most unique volcanically active areas in the world. Beneath the park lies a massive magma chamber that has the potential to cause a volcano unlike one experienced in the modern era. Fortunately, these events are very rare, as geologists have found there have been just 3 caldera-creating volcanoes in the last 2.1 million years, the latest one occurring 640,000 years ago. When they erupt, these volcanoes create what is known as the Yellowstone caldera, a base where scientists from all over the world come to study volcanic activity. Since the last large volcano, the area has remained active with volcanic activity, including less energetic lava flows that can sometimes travel for over 100 miles. These lava flows hold a much more viscous type of lava than the larger explosions, but demonstrate that the area is indeed still quite volcanically active. The Yellowstone caldera is also host to much more common, less dangerous events such as small earthquakes and geysers. Shown on this slide is Old Faithful, Yellowstone's encapsulating image. Geysers like this one occur when the water goes deep underground where the superhot magma lies. Because the water experiences immense pressure underground, it is able to remain in a liquid phase at extreme temperatures. The water then bursts back towards the surface of the area and into the sky, creating the geysers. These geysers can sometimes be powerful enough to push rock up into the sky, but typically tourists are able to view them from a safe distance. The magma chamber is also the cause of a great deal of seismic activity in the area, as the Yellowstone area experiences on average 2,000 earthquakes per year. Most of these earthquakes are so benign they can't be felt. However, in 1959, a 7.5 magnitude earthquake struck the area and did some meaningful damage to nearby buildings. Yellowstone is an excellent case study for volcanism because it shows us why the topic is such an important aspect of geology. Not only does this specific magma chamber hold potential for an earth-changing event, it also creates some regularly occurring phenomena that draws people from all over the world. We hope you enjoyed our video on volcanoes. Thank you for your time.